Good morning, Year 6. Welcome to our Tuesday math lesson. Today is the 19th of May 2020 and today we are going to be using a formula to calculate the volume. So can you write down today's date and the date in Roman numerals and our learning intention for today? Fantastic, we'll begin. For today's lesson you will need a pencil, something to write with, you'll need a piece of paper, and you'll need a 5-minute timer, which you can use on another tab, as we usually do. Fantastic. So, before we go on to today's lesson, you'll remember yesterday we explored making simple formulas through the function machine, and you have learnt how to find the area of 2D shapes in earlier year groups. Today we explore how to find the volume of 3D shapes. So make sure you've completed these lessons before going on to today's lesson. Make sure you're confident with finding the area of 2D shapes before we go on to looking at 3D shapes. And if you need any help on those, you can always go to Khan Academy and recap lessons on finding area. Okay, so just as we usually do, we're going to go on to our starter. So I'd like you to pause the video here, set your timer, and have a go at answering the questions shown on screen. Fantastic. We'll go through the answers. I'm just going to whiz through the answers here, and then on the next screen I will show you how you could have found those answers that you didn't know. So we've got our greater than symbol. The answer here is 183,475. 1/8 plus 3/4 equals 7/8. Alison has 5 different coins in her purse with a value of 68p. What are the coins? 50p, 10p, 5p, 2p and 1p. And Alison says, a cube has 6 square faces. Each face has 4 sides, so therefore a cube has 24 edges. Is Alison correct? Well, a cube has 12 edges. Alison is not correct, and it seems that Alison has counted some edges twice. So see how well you did there? If there's any of those that you found tricky, then we're about to go on to how you could have found these answers. So now we're going to go through how we could have found those answers. If you found those answers quite easily, then I would say, and you got them all correct, then just skip through this part and go to the next part of our video. But otherwise, we're going to go through how we could have found those answers together. So you'll see on the place value section, we can see we've got the number 272,722 compared to the number 272,277. And if we compare both those numbers, we need to start off with the largest column, the largest place value in each of those numbers, which is 100,000. Both of those numbers only have a 2 in the 100,000s column. They both have a 7 in the 100,000s column, in the 10,000s column. They both have a 2 in the thousands column, and it's not until the hundreds column that they differ. When we get to the hundreds column, we can see that one of the numbers has 7 hundreds, whereas the other number has only 2 hundreds. And that makes it easy to compare. So then we can see that 272,722 is greater than 272,277. And with our symbols, we know that we've got the greater than, less than, and equal to symbol, and the part that is widest faces the larger number. Okay, so the sign opens towards the larger number. Now for our calculation in algebra, it says, use a written method to solve this calculation. 7,339 multiplied by 25, and there we'd need to make sure that we multiply the 7,339, we multiply it by the 5 first, and then we multiply it by the 20. Okay, so we do 9 times 5, 3 times 5, 3 times 5, 7 times 5, and then when we go on to do 9 times 2, we must remember to put in this first. That's right, we need to remember to put our 0 first, and then we carry on multiplying the numbers, and then we need to remember to add them together, and we'll get our answer, 183,475. Fractions. Add together these fractions. We've got 1/8 plus 3/4. In order to do that, we know that the denominator needs to be the same. It makes it much easier to add together when the denominator is the same. So let's convert our 3/4 into eighths. What do we need to multiply 4 by in order to turn it into an 8? 8. Super, we need to multiply it by 2. Whatever we multiply the bottom by, we must multiply the top by. So if we multiply the 4 by 2 to get to 8, we multiply the 3 by 2 to get to 6. So then we have 1/8 plus 6/8, which equals 7/8. Problem solving. Alison has 5 different coins in her purse with a value of 68 pence. What are the coins? So you can see on the screen I've shown you all of the coins that we use here in England. So we know that she has 5 different coins. So there's no coins in their purse that she has the same of. So we need to bear that in mind. Now I would start off by working out, by trying to find how she's got the 8p. So I would add together the 5 plus the 2 plus the 1 and I get 8 pence. Now I need to put together the 60 pence. So the 50 pence plus the 10 pence gives me 60 pence, and voila, we've used 5 coins and they're all different. For the reasoning, Alison says that a cube has 24 edges because she's multiplied the 6 square faces by the 4 sides on each face. But we know Alison's incorrect because she's counted the same edges twice. And we can see on the cube that's rotating, we can see that even on the faces that we've seen, even if we look at the faces that are opposite to each other, and we count each of the edges on those, then when we're counting the ones in between, we're just counting along. So she's counted far too many. She's counted them twice. Well done if you managed to get those. Now we're going to go on to a quick recap lesson. So this is where we looked at our function machines, and we're going to think about our function machines to help us find the value of the variables. Remembering the variables are our letters, okay, that are being used to represent numbers, unknown values. If we have y plus 15 equals 26, how could you use, what method would you use to find the value of y? Well, you'll need to remember to use the inverse. So bearing that in mind, I'd like you to pause the video and have a go at solving the problems on screen. Fantastic. Now let's go through the answers. We need to do the inverse, so we're going to start from 26. 26 minus 15, which gives us 11. So the answer to the first one, y equals 11. Now for the second one. 7a minus 12 equals 51. A equals 9, and we know that because we need to do 51 plus 12, which gives us 63. And then we do 63 divided by 7, which gives us 9. So our answer there is 9. For 9a plus 20 equals 47. Again, we do our inverse. So 47 minus 20 is 27. 27 divided by 9 is 3. So a has a value of 3. Now in the one at the bottom, it says in this expression, a and b are positive integers. So we've got a plus b equals 12. That means they're positive numbers, okay? So write all the possible values of a and b. So a could be 1 and b could be 11. A could be 2 and b could be 10. A could be 3 and b could be 9. And in fact, we could keep going with a being 4, 5, 6, 7, 8, 9, 10, and 11. We could keep going there. Okay, so those are all the possible values of a and b. Well done if you managed to get those. So we're going to recap some key vocabulary that we're going to see a lot as we're covering our unit. So formula, and if you see the word formula, it means the singular, and that means one. It means we're just talking about one. But if we're talking about the plural, then you'll hear the word formulae. Okay, and the formulae means the plural more than one. So just bear that in mind when you hear the two words. So we're going to be looking at volumes of cubes and cuboids. To calculate the volume of a cube or cuboid, you could count the cubes in each layer. So you could easily just sit and count them all. 6 cubes at the top, add them together, 6 plus another 6 plus another 6 plus another 6. You could do it like that. And you'd have 24 cubes. Or we have an even better way. which could be to multiply the length by the width by the height. And that is the formula that we use to find the volume of a 3D shape. So you can see in this case, we've got 3 going across. The 3 is our length. It has a width of 2 and a height of 4. So if we multiply those together, we get 3 times 2 times 4, which also equals 24. We know that we can rearrange those numbers as well, and we'll still get the same answers, okay? Because we know that multiplication is commutative. It doesn't matter which way around our numbers are, we're still going to get the same answer. So length times width times height gives you the volume. If each cube was 1 centimeter cubed, the volume of this shape would be 24 centimeters cubed. Okay, so if in terms of our units of measure, if we're talking about if each cube is worth 1 centimeters cubed, then the volume of the shape is going to be 24 centimeters cubed. But if each cube was 1 meter cubed, then the volume of this shape would be 24 meters cubed. And you'll remember in yesterday's lesson where we talked about, I think it was Harry, and he gave his answer as squared, which is fine if we're discussing 2D shapes, but when we're discussing the volume of 3D shapes, then we need to make sure we're using cubed because we're measuring, it's a 3-dimensional shape. Okay, so the 3 dimensions are length, width, and height. Okay, whereas with a 2D shape, we're just measuring the length and the height. There are only 2 dimensions, so our answer is going to be squared. But with the volume in 3D shapes, we're using cubed because we're measuring 3 dimensions. How could you write an algebraic statement to show how to calculate the volume of a cube or cuboid? Pause the video here whilst you think about that question and see if you can answer that question. Super. So just as we just discussed, it would be volume equals length times width times height. We don't need to use the multiplication symbol, so the formula would be written as V equals LWH. V standing for volume, L for length, W for width, and H for height. In this cuboid, we have the length, which is 3. The width, you can see that's how far back it goes, that is 2. And the height, how tall it is 4. So it's 4 cubes high. So if we multiply that length, width, and height together, we get 3 times 2, which is 6, and 6 times 4, which is 24. So our answer there is 24 cubes, and our volume then is 24 centimeters cubed, if each of those blocks are worth 1 centimeter cubed. So volume of cubes and cuboids, we have a little task for you. With the formula shown on screen, I'd like you to calculate the volume of each of these shapes. Use centimeter cubed or meter cubed in your answer. So always look at what unit of measure is being used in the question and make sure you use the same unit of measure in your answer. Pause the video here whilst you complete this. Fantastic. So your answer should have been, for the first cuboid, we've got 5 times 5 times 8. That would have been the formula that you would have used, the length, width, and height, and you would have got 200 meters cubed. 200 meters cubed. Because we know that 5 times 5 is 25, and 25 times 4 gives us 100, so 25 times 8 gives us 200. For the second one, 4 meters times 5 meters times 6 meters, and our answer there was 120 meters. We know that 5, even remember I said it doesn't matter which way around we move the order that we do them, because with multiplication it's commutative, meaning that it doesn't matter what order we do it in, we still get the same answer. So 5 times 6 is 30, and then 30 times 4 is 120. So our answer is 120 meters cubed. And last but not least, we have 3 times 3 times 6, and our answer there would be 54. knowing that 3 times 3 gives us 9, and 9 times 6 is 54 centimeters cubed. Make sure you double check that you've got the right units of measure in your answer as well, and that you remember to put our little 3 there, our little indice 3, to show us exactly what that we have multiplied in, that we're working with three-dimensional shapes. So volumes of cubes and cuboids. Got a few problems here, and I just want you to see if you can use the information given to help you solve the problem. Do these shapes have enough information for you to be able to use a formula to calculate the volume? And if yes, use the information given and calculate the volume of the shapes. So look at each shape individually and then work out, can I work out the volume of each shape using the formula shown on screen, V equals LWH, so volume equals length times width times height. Do you have enough information to be able to find the volume of the shapes? Pause the video here whilst you work it out. If you can't work it out, then explain why you can't. Fantastic. Let's go through the answers. So for the first one, yes, we can find the volume of the shape because even though we've only got 2 dimensions, we can still work out the volume. We can see that we've got 2.5 meters is the length of the face of one of the shapes. But even without knowing the height of that shape, we know that the area of that face is 12.5. So we can just use that 12.5 meters squared, because that's the area of the face, and multiply that by 2. Okay, so 12.5 meters squared, we multiply that by 2, we get 25 meters cubed. Okay, because we know the width multiplied by the height is 12.5. And then from that, we can just multiply that by the length to find the volume. Now for the second shape, we have a cube. And we can see that we have the width of the cube is 8 centimeters. So we know that with a cube, all of the dimensions are the same. So it would just be 8 times 8 times 8. So our answer is 512 centimeters cubed. Now on to the last. We can work out the area of the face of one of these, of the face on one side of this cuboid, but we don't have enough information to work out the volume. We know that 9 times 3 is 27, and that tells us the area of one of the faces, but we need to know a bit more to be able to work out the volume. So no, we can't work out the volume on the third shape, only on the first 2. Well done if you managed to get those. Here is the net of a cube. The faces of the cuboid are 4 identical rectangles and 2 squares. Do you have enough information to calculate the volume? And if you do, what would the volume of the shape be if it were made into a 3D shape? Pause the video here and see if you can work out the volume. Fantastic. Yes, we can work out the volume. The length of the shape is 6 centimeters. The height and the width are both 3 centimeters because the end faces are squares. The volume then is 6 centimeters multiplied by 3 multiplied by 3, which equals 54 centimeters cubed. Now here is the net of a cube. The area of one of the square faces that the cube is made up of is 25 centimeters squared. Do you have enough information to calculate the volume? And if you do, what would the volume of the shape be if it were made into a 3D shape? So pause the video here. Can you find the volume of this cube? What do you know about a cube that might help you with this question? Excellent. Let's go through the answer. If the area of a square face is 25 centimeters squared, then we need to find the square root of 25 centimeters. The square root of 25 is 5. So now we know that all of the dimensions are 5 centimeters, and we can use that to help us using the formula, length times width times height. So we do 5 times 5 times 5, which gives us 125 centimeters cubed. Well done if you managed to get that. Now it's over to you. I'd like you to use a formula to calculate the volume. Looking at the sheets shown on screen, they would have been emailed to you this morning. So choosing your level of difficulty, you're going to be using the formula to help you find the volume of the shapes. So well done, we've completed our lesson using a formula to calculate the volume. And now I'd like you to remember to email us your work at yr6@grange.harrow.sch.uk. If you're having trouble printing off the worksheets, you don't have a printer at home or anything like that, then you can work off the screen and just write down your answers by just labelling clearly so we know exactly which question you've answered. Okay, so just making sure you put 1 and then put in your answer, 2 and put in your answer quite clearly. And if you want to, you can even put the calculation as well. Makes it a lot easier for us when we're having a look at it. Have a great day. Bye bye.